If you would be asked at this moment how to differentiate this function, would you know how to do it? Actually, if you look at it, you would know something. There is a trick on your sleeve that would allow you to solve it. Because you can turn this into the product of two polynomials. This one you know how to expand. Then you would cross, multiply, and simplify. And you would have another way of representing that as the sum of these four terms. And each one of them you know how to differentiate. So f dash of this will be that then simplified would be just this. This takes a lot of time, so the purpose of this lesson is for you to learn a more straightforward method that allows you to get to these results in not a split second, but in just, I guarantee that if you know how to do this later on, you can differentiate this in 3 seconds. Okay? Just trust me. It seems that if you look at it in the beginning, that is too complicated. It's not. Okay? It's a very straightforward method if you understand the notation, and that's what I'm going to explain step by step in the next few minutes. The method is called the chain rule. All right, and I'm going to explain first, and you are going to be scared because you are not going to relate this to anything in specific. But then you are going to when I start using specific examples, you are going to see what all of this means. All right. So what if you have an expression that seems complicated, such as this one, and you are asked to differentiate? You can think of that original function as composite functions, in a way that you have a smaller function as part of a bigger function. Okay? So if you have that more complicated function that is made out of two simpler functions, which I'm going to call g of x and f of x, okay? I can call each one of them u and y. And then if I want to get the value of dy by dx, that is, if I want to differentiate the bigger one, I can think of it as the product of this one differentiated in relation to x, so du by dx, that's what you have over here, times this one differentiated, that is dy by du. And then you multiply them together, and then eventually that is going to be equal to the thing that you are looking for. You didn't understand anything, right? So let's look at this example again, which is the one that I had before. So your y is the original complicated function, so 2x plus 3 to the power of 3. Okay? What is the smaller function, this g of x that I was talking about? It's going to be the thing that you have over here, the 2x plus 3. So I'm just going to call 2x plus 3 u. Can call it whatever you want. Usually I call it u, and in textbooks you'll see it as u. All right? So if you call this 2x plus 3 u, this is going to be a smaller function, the one that I have over here. U equals 2x plus 3. And your y is going to be what now? It's just going to be u cubed. Again, if this is u, then y is going to be equal to u cubed. And u is going to be equal to 2x plus 3. That's the only thing that I have here. What is the advantage of this? You can differentiate these very easily. This is basically, you are just differentiating u in relation to x, so du by dx, okay? And that is just 2. And here you are differentiating y in relation to u, so that's dy by du, and that is 3u to the power of 3 minus 2, that's 3u squared. What do you want to begin with? You want dy by dx. So what is dy by dx? That's going to be dy by du times du by dx. What are we talking about in this specific case? Dy by du is 3u squared. Du by dx is 2. So this is what? This is 6u squared. What was u again? U was 2x plus 3. So the final answer is dy by dx equals 6 times 2x plus 3 squared. That's what you would get if you use this very long, complicated, and time-consuming method. Did you get it? The notation seems complex, but it's actually very simple. Again, you are breaking down the complicated function into two smaller functions. Just isolate the smaller function. Usually, this is in between brackets, or this is a square root, okay? If it is a square root, you can put whatever the content that you have in a square root as something to the power of 1/2, right? And you call it just u. Then differentiate that bit. The original function is just going to be u to the power of whatever. Differentiate that, okay? Multiply them two, and then undo, simplify whatever you need to simplify. In this case, it's just 3 times 2. And then undo what you did before. So your u substituted back by what u actually is, and that's your final answer. Let's look at another example. X squared plus 3 to the power of 4. So your u is going to be x squared plus 3, and y is going to be u to the power of 4. Now differentiate u in relation to x, that's just 2x. Differentiate y in relation to u, that's just 4u to the power of 3, 4u cubed. So dy dx, that's what you wanted to begin with. It's just going to be dy by du times du by dx. So that's 4y cubed times 2x, which is basically 2x u cubed. And then substitute u by what u is, which is x squared plus 3. So differentiating this, you can do this, okay, 30 seconds, maybe. You can get very easily the expression for all gradients of that. Actually, you can turn these 30 seconds into, as I mentioned before, 3 seconds. But if you are at this point and looking forward to get the shortcut of the shortcut, I invite you to practice enough using this method so that you let sink in the structure of your mathematical knowledge, so to speak, what the chain rule is. Because there is a class of questions that I'm not mentioning in this lesson, and that it appears in 90% of the exams, that relate to real life, and the shortcut of the shortcut is not going to help you much solving, okay? And in the lessons, in the exercise lessons that I have after, I have 2 or 3, depending on what tier you are. You'll have either 3 or 4 or just a couple. I can't remember right now how many I put as exam questions. But they use this structure over here, okay? So take your time to practice using this method, because this is very important for you to understand what the chain rule is, all right? But then there are situations in which you just have to use a chain rule to get the derivative of a function, to find something else, for example, the monotony of the function or whatnot. And in that case, there is a shortcut of a shortcut, which I usually express like this. So if you have an expression, a polynomial expression to the power of something, don't forget that this may be, for example, a square root or a cube root or whatever root, in which the something over here may be a fraction, okay? And this is a polynomial expression. Then if you want to differentiate that, and I represent that as just y dash, then it's going to be just whatever that thing is, that's something, times the polynomial expression itself differentiated, that's why you have the dash there, times the polynomial expression as is to the power of something minus 1. Seems complicated, right? You can actually solve this on the time that it takes to write this line, okay? So, again, polynomial expression to the power of something. If you want to get the derivative of y, so y dash is just the something, 4, times this differentiated, the polynomial expression differentiated, which is just 2x, times the polynomial expression as is to the power of something, 4 minus 1, 3. So 4 times 2, that's just 8x, times, open brackets, x squared plus 3, close brackets, cubed. How much time you need to solve this? Okay, it's 3 seconds, probably too little, but what, 10? 10 seconds, just the time to write the line, if you know how to do this very quickly. You have now square root of 2x plus 2. You can rewrite this as 2x plus 2 to the power of 1/2. So let's just apply that. Y dash equals 1/2 times this differentiated, which is just 2, times this as is to the power of 1/2 minus 1, which is minus 1/2. Then this 2 cuts with that 2, so you just have this to the power of minus 1/2, which is just 1 over square root of that stuff. One more example. Now let's say that you have this one to differentiate. So what is this? This is 2x plus 2 to the power of minus 1/2. So y dash is going to be what? It's going to be the something, which is the minus 1/2, times this differentiated, which is just 2, times this as is to the power of minus 1/2 minus 1, which is minus 3/2. So then again, this 2 cuts with that 2, so you have just minus this to the power of minus 3/2. And what is that? That's just 1 over square root of 2x plus 2, the whole thing cubed.